This is part 3, the graphs of sinusoidal functions. The amplitude can be determined from a graph by the following formula. Amplitude is equal to max minus min, all divided by 2. The equation for midline is pretty much the same, but instead of going max minus, we go max plus min divided by 2. Remember, the period is the horizontal distance from max to max or min to min. It can also be found by doubling the distance from max to min as the graph is symmetrical. The domain will always be the set of real numbers unless some restrictions have been placed on it. For example, if we're dealing with an actual practical application where we can't have a negative time, for example. The range can be found using the formula r equals y such that the minimum is less than or equal to y, which is less than or equal to maximum. Y belongs to reals. So all you got to do is just sub in max and min, and you're golden. Okay, so here's a little graphic to help you see where all these things are. So again, period from max to max. It could also be from min to min. Okay, but remember, not from x-intercept to x-intercept. It's from x-intercept to the next x-intercept. Okay, assuming that not necessarily x-intercept, but where the graph crosses the midline. Okay. So that can also be the period. Amplitude from midline to max or from midline to min. That distance should be the same. Okay, so let's try some examples with this newfound knowledge. Determine the range, amplitude, period, and equation of the midline of the sinusoidal function. Okay, so let's start with the range. Okay, again, we want minimum less than or equal to y less than or equal to maximum. So the minimum looks to be here at negative 1.5. Okay, and the maximum looks to be at 0.5. Y belongs to reals. All right, now that I know the max and min, I can use my formulas for amplitude and midline. So amplitude is equal to max minus min all over 2. So my max, that should be negative 0.5, is negative 0.5 minus negative 1.5 all over 2. So minus minus is plus, so that's negative 0.5 plus 1.5, which is 1, divided by 2 is 0.5. Okay, so the distance from the middle to that is 0.5. Okay, remember again, amplitude is not negative. Let's find the midline by doing the same calculation except for adding the max and the min. So that's max plus min divided by 2. So my max was negative 0.5 plus my min of negative 1.5 all over 2. So add those together, you get negative 2 divided by 2 is negative 1. So there is our midline. Looks about halfway in between. And again, this distance is 0.5, and so is that distance. Okay, last thing we have to do is find the period. So period is equal to, now in this case, I don't have max to max or min to min, but I do have the distance between the maximum, so that's when x is 1.0, to the minimum at a distance of 2.0. Okay, so the distance from here to here is 1.0, but remember, I have to go max to max or min to min, so I can double that distance. So 2.0 minus 1.0 times 2 gives me 2. Okay, good. I think we got everything. Okay, and remember, sorry I forgot, when it says equation of the midline, you actually have to write that as a y equals negative 1. Okay, good. All right, next example. Next page. All right, again, I have already pre-scaled my graph, so you may want to stop the video and do the same. Now, something I made a mistake on here. Please note that the domain is between 0 and 360. Well, if I scale it the way I have, I don't actually have enough space for 360, so you might want to just add in one more little row here on the end so that we have room for that good old 360. Okay, when you're done scaling, turn the video back on. Okay, so we have our domain between 0 and 360, so we should be starting here at x is 0 all the way to x is 360. Okay, good. The range is from -5 to 9. So notice I have a -5 here and a 9 up here. The period is 120 degrees. Okay, so how many cycles are going to fit in 360 degrees? We should be able to get 3 in there because 360 divided by 120 is 3. The y-intercept is 2. So I'm actually going to start by graphing that. Where the graph crosses is at 2. Okay, so now that's going to become, go to my maximum, okay, and that will be at 30 degrees. Okay, and then we're back down at 60, because again that's half the period, so we should be getting all the way to the max and back down. And then for another half the period, so at 90, that would be at -5, and at 120 we should be back up here at 2. So there's one full cycle from the midline to the max, back to the midline to the min, and back to the midline. That's one full cycle. And remember, the period is 120, so that should happen in 120. Good. Again, we still have to go all the way to 360, so we're going to draw another cycle. Okay, so 150 up to the maximum. Okay, at 180 back to the midline. At 210 to a minimum. And again, 240 back to the midline. Remember, 120 plus 120 makes 240, so that should be another full cycle. Here, I'm connecting with a nice curvy line. Good, one last time. So 270, draw maximum. 300, we're back at the midline. 330 at a minimum. And 360 at a maximum. Or back at the midline, sorry. And again, connect the dots. Great, so between 0 and 360, we should have 3 maxes, 3 mins. Okay, all right, and there's my midline. So it might help to draw that in too. Okay, now this isn't the only graph I could have drawn for this particular set of instructions. We could actually have started on the y value of 2 and gone downward instead of going upward to start with. So it would just look like it had been flipped over the midline. Okay, so again, there's more than one answer to some of these questions. All right, example number 3 says to determine the range, amplitude, period, and equation of the midline of the sinusoidal function. So pretty much the same as example 1. Okay, so range, we'll start with that, is equal to the min. So the min, these look like they're 0.25s. 0.25, 0.5, 0.751, yep. So my min then is at 0.75, less than or equal to y, less than or equal to, and my max, so that's 2, 2.25, 2.50. Okay, I think. Yeah, 2.50, okay. And again, y still belongs to reals. Okay, all right, amplitude. So that's going to be max minus min divided by 2. So my max is 250 minus a min of 75 all over 2. Okay, so that would be 1.75. So half of that would be 0.875. Okay, so that's my amplitude. Good. Let's find the midline. So again, we're going to go max plus min divided by 2. So my max was 2.5 plus 0.75 divided by 2. So that would be 3.25 divided by 2 is 1.625. Okay, so 1.25, 0.5. So it should be right about here-ish, somewhere in there. Okay, great. And again, remember, because it's an equation of the midline, we have to write it as y equals 1.625. Okay, last thing we need to find is the period. Okay, so I have definite maxes to maxes. So I start here when x is 0. Okay, and I go to my next maximum. That occurs when x is 2, so the period should be 2. Okay, the next maximum is at 4. So again, period, still 2, but from one maximum to the next. Good, should work even if I chose minimums. So from 3 to 5, also a difference of 2. Okay, great. Feel free to take on the practice from page 506. Show your teacher when you're finished.